Hello everyone. In this video, we will look at the discrete probability distribution from chapter 5. So in previous lecture, we learned different variables, and we mainly focused on how can we use different tools to summarize the data. And again, I want to emphasize, before you decide the tool to summarize the data, you need to decide whether the variable is a categorical or quantitative variable. Then try to find the corresponding method to describe it. So in this chapter, we will look at how can we use different statistic way to measure the discrete variable and a continuous variable. So in this chapter, we will learn a random variable, expect value and variance for discrete random variable, and the special case of a discrete random variable called the binomial probability distribution. First, let's talk about the random variable. So many of you have already heard this term random variable from your previous math class. So the definition for a random variable is a numerical description of the outcome of an experiment. I hope many of you still remember our Excel Home 1 data set. So we have one case is about pelican stone. And the manager are really very interested to know the customer's characteristic, and also they want to know the effectiveness of the discount coupon. So in the data set, we found that there is one variable called age. So the age is an example for random variable. Why? It is because if we randomly go outside to pick a customer from Pelican store, and we will ask them, what's your age? And different people will give you different numbers. So that is a numeric description of the outcome of an experiment. So for random variable, we need to distinguish we want to categorize it into two categories. One is called a discrete random variable, another is called continuous random variable. So a discrete random variable may assume either a finite number of values or an infinite sequence of values. Such as, if I ask you how many bottled water do you drink every day? So you probably will say 1 bottle, 2 bottle, 3 bottle, instead of saying 1.2 bottle or 1.275 bottle. So we count the number of the bottles. And another thing I want you to pay attention on deciding whether the variable is discrete or continuous random variable is the fully understanding of a discrete random variable. So if I ask how many gallons of the milk do you usually buy from the Walmart? So normally people will say 1 gallon or 1.5 liter. So does that count the variable as continuous random variable? The answer is no. It's still discrete random variable. Although some people will say 1.5 gallon, so it's just a measurement unit difference. So people will say 1.5 liter or 3 liter or 4.5 liter. So everything is still count the number. So for a continuous random variable, many assume any numeric value in the interval or collection of the intervals. So again, think about the money to cut your hair. Can it be any numeric value? Obviously, no. It's because if you go to the hair salon, if the hair cutter charge you $2.7564, will you think that's a right price? Do you think it's a weird salon? Obviously, you will say yes. So the continuous random variable will be characterized by that the variable can be given any numeric value in the interval or collection of intervals. So let's look at some example related to the discrete variables. So the first is let x this example is about the JSL appliance. So we first define the random variable x. So So the X is number of the TVs sold at the store in one day, where X can take on 5 values, 0, 1, 2, 3, 4. So obviously we count the TV sold, and there is a finite upper limit on the number that might be sold. So we call it finite discrete random variable. So can you give me some more examples? So for instance, if I said every day I can only drink 5 cups of water, so the 5 is the maximum. So for one day I can drink 0 cup, 1 cup, 2 cup, 3 cup, 4 cup, and 5 cup. But I have an upper limit that is 5 cups. And again, so my example is also counted as finite discrete random variable. So how about the infinite discrete random variable? So let's define the random variable X is number of the customer arriving in one day, where X can take on the value from 0 to positive infinite, right? So you cannot put the upper limit for the customer arriving in the store. If you're the manager, you definitely hope the more customer, the better. So we can count the customer arriving, but there is no finite upper limit on the number that might arrive. So let's look at more examples related to the discrete and the continual random variable. So the family size. So the question is, what's your family size? And we will define random variable to measure the family size. So the random variable X is called a number of the dependent report on the tax return. And so we know the people can be 1, 2, 3, 4. It cannot be 1.5. Maybe you will joke around. Maybe one of the family member have the baby. But if he has the baby, you still need to count 1 more people for that household. So no matter what, the number of the people, the number of the dependents are counted as discrete random variable. So my question is that finite or infinite? Yes, it is finite. It's infinite discrete random variable. But by the way, if you're born in some country, they have the policy to regulate the baby birth, how many baby they can have. So in that scenario, we are talking about infinite, finite discrete random variable. And question number 2, if you want to know distance from home to store, and the random variable you will use to measure the distance from home to store is distance in miles from home to the store site. So pay attention on the relationship between question and random variable X. Since the random variable will be used to measure the outcome, so you need to pay attention on the unit. When you define the random variable, you need to also define the unit. So in the second statement, we're looking for the distance. So the distance is measured by the miles. And we know if we talk about distance from home to store, it can be any positive real numbers. So obviously we are talking about the continual random variable. How about the last one? Own dog or cat. So the X equal to 1 if own no pet. X equal to 2 if own dogs only. X equal to 3 if only own cat only. X equal to 4 if own dog and cat. So we know that we are using the number to define the categorical data. No matter what, we are looking at a discrete random variable. So after we know the different kind of random variable, and we are looking at this probability distribution. So the probability distribution for the random variable describes how probability are distributed over the value of the random variable. So what's the relationship between the variable and the probability distribution for a random variable? So the probability distribution for a random variable is telling us the track of each random variable, how they move. It's more like if you see some people from Asia, and once you know which country of Asia he or she comes from, you can guessing what kind of characteristic he or she has. So you will know, for instance, if he or she coming from China, and you definitely know they will celebrate the Chinese New Year, so which just passed last week. So we can describe the discrete probability distribution with a table, graph, or formula. So when we talk about how can we describe random variable, or how can we describe the movement of the random variable, we can use either table, graph, or formula. So the following slides, I will show you how should we use a table, graph, or formula to describe it. And before we talk about different ways to describe discrete probability distribution, and we want to emphasize two types of discrete probability distribution in this chapter. So the first we will learn is we will use the rule of assigning probability to experimental outcomes to determine probability for each value of the random variable. Try to link this concept with the previous concept of assigning probability. And the second type is use a special mathematical formula to compute the probability for each value of the random variable. So the probability distribution is defined by the probability function denoted by fx. So the f actually is the initial for a function that provides the probability for each value of the random variable. So we know that since the requirement for the probability, so we also have the condition for a discrete probability function. So the first is the discrete probability function should be large and equal to 0. As we mentioned before, the probability cannot smaller than 0. And the second is if you sum all the probability together, it should be equal to 1, because the probability distribution reflect reflect the probability for all the possible outcomes for the random variables. So therefore, if we consider all the possible outcomes for the random variable, the probability corresponding to each outcome, if you add all of them together, should be equal to 1. And before we learn, there are three methods for assigning probability to random variable: classical method, subjective, and relative frequency method. As I mentioned before, the classical method is the first method people explore, the statistician applied. And after that, we have the relative frequency method. It relies on a lot of experiment. And the subjective method is more popular nowadays. It always goes with the classical method and the relative frequency method. So the use of the relative frequency method to develop the discrete probability distribution lead to what is called empirical discrete distribution. So let's look at the JS appliance example again. And we're using past data on TV cell, a tabular. So first we can look at the grid table. So this is what we've already seen before. It's a tabular representation. It's a frequency distribution. And we know the unsold from 0 to 4, and we can name it as x. So the x will be our random variable. It represents the unit sold, and the possible value is from 0 to 4. So remember what I said, it's a possible value. So it cannot sell 5 units. So the maximum they can sell is 4 units. And now we want to get the probability for each possible outcome. So for instance, what is the probability for the GSL appliance cell has no cell? So what we are doing is we calculate the relative frequency based on the number of the days. So we have within 200 days, 80 days we have sold nothing. So we use 80 divided by 200. And we got 0.4, so the probability for the unit sold equal to 0 is 0.4. So we will use a similar method to calculate probability corresponding to x equal to 1, 2, 3, and 4. So now we can go look at the blue table, and try to think about the probability for the discrete probability distribution. So all of these probability are larger than 0, and if we add all 5 probability together, we got 1. So this blue table is table of tabular display for the discrete probability distribution. And as I mentioned, we also can use the graph. So here we are looking at this graph. It's more like a bar chart. Do you remember the difference between bar chart and histogram? The difference is between there is no gap between two rectangles for the histogram. If we say there is a gap between two rectangles, we think it's the bar chart. So obviously we are looking at the random variable. So the x equal to 0, 1, 2, 3, and 4 will count and treat it as categories. So the 0 appliance sold, or 0 TV sold, 1 TV sold, 2 TV sold, 3 TV sold, and 4 TV sold. But the difference is our vertical axis. Before we are using the frequency, but obviously now we are using the probability. But as you already know how to calculate this probability, actually they are relative frequency distribution. And they are relative probability, relative frequency. So in addition to table and graph, a formula that gives the probability function fx for every value of x is often used to describe the probability distribution. So several discrete probability distributions specified by formula are the discrete uniform, binomial Poisson, and hypergeometric distribution. However, in this class, we only focus on binomial distribution because the binomial distribution will have more application in business. So in next video, we'll talk about how can we calculate expected value and variance for the discrete probability distribution.